oftentimes in object-oriented programming, we are aware of the concepts or we are aware of the principles but do not know how to put them in effect. Or it may also happen that we are writing fairly good programs but do not know or do not understand how and where the object-oriented programming principles that we had learned previously are being applied. So in this question, I will try to clarify these two fronts. Okay, I'll try to make you understand the relationship between the object-oriented programming principle and how it is put into effect in your programs. Okay, so let's do this. Now, as you can see, I've been given two columns here, two lists, and I have to match them. So now the first option is encapsulation. So what is encapsulation? Now encapsulation means to wrap up or to put in place the data and functions that operate on the data into a single unit. And this single unit is called a class or an object at times. So if we are talking about encapsulation, then the programming feature that is used to implement encapsulation would be a class. So you would implement the object-oriented programming principle encapsulation using a class. So I've got the first option, that is 1C. Okay, so how does this happen? I'll just take an example. Let's say I have a class. Let's say the class is car, and I have, let's say, a few data members. Let's say I have a private data member, okay, int number of doors and float price, and I have a couple of public members. Let's say void get details, and let's say int get price. Right? So my class has two data members and two member functions. I have simply declared my member functions. I'll be defining them outside the class. Now, what happens here is we are having a class by the name of car, and inside that class we have data members. These are my data members and my member functions. So I've taken my data members and I've taken my member function and I've put them together at one place, and this one place is called the class. So what am I doing? I'm taking my data and I'm taking my functions and I'm putting them together. I'm wrapping them up into a single unit called class. That's why encapsulation is implemented using a class. Right? Now see, the next one is data hiding. What is data hiding? Data hiding means to protect the data of your class or to protect the data members from unauthorized access. If data of a class has to be accessed, it should be done through an authorized interface, and that authorized interface is usually a member function. That's why the recommended approach is to have public member functions and private data members, so that the data members cannot be accessed directly outside the class. If they have to be accessed, it has to happen through the member functions because they act as the interface to the data, right? So if you have to implement data hiding, then what you would do, you would have your data members in such a way that they are not accessed directly outside the class. And how do you do that? You do that using the access specifier private. So we have three access specifiers: private, public, and protected. If you use the private access specifier, what you will do is you will conceal your members, whether it be data members or member functions, from access outside the class. So if I'm having these data members as private, it means they are hidden from outside the class. But they can be accessed, mind you, by members which belong to the same class in which they are declared. That means I have two data members, they belong to the class car, and I have two member functions. They also belong to the same class. That is why these member functions can directly access these two data members. Let's say I have a function like this, void f, right? And this function has been defined outside the class. See, this function will not be able to directly access these data members. This is what data hiding is all about. But can it access these data members? Can it do it indirectly? Yes, it can. If this function, not a member function, these are my member functions which are part of a class, and any function which is not part of a class is not a member function, right? So this is not a member function. This function, if it wants to access these data members or work on these data members, it has to go through these member functions. So it has to invoke one of these member functions. Since they're public, they'll be available to all entities, whether inside the class or outside the class. So f will have access to these public members, and it can access these data members through these member functions, right? So if I have to implement data hiding, I have to use the access specifier private. So data hiding will go with private. So that is 2D. Okay. Now the next one. Next is polymorphism. What is polymorphism? Polymorphism refers to one entity, multiple forms, right? For example, I am right now playing the role of an instructor, trying to help you with C++ programming. I am also at the same time a son to my mother. I am a brother to my sister. So I am one person playing different roles. Similarly, polymorphism is all about having one entity play different roles. And remember, polymorphism can be implemented at two times. It can be implemented at compile time and as well as at runtime. Polymorphism, when implemented at compile time, can be done through function overloading or operator overloading. And when it is implemented at runtime, it can be done through function overriding. Since the only option that is given here is function overloading, polymorphism will go with option A. So number 3 goes with option A. So what is function overloading? We'll have one function name which takes in either different numbers of arguments or different types of arguments or both, and we will use that one function name to implement different functions. Just like I said that I am one person who plays different roles, similarly one function will play different roles based on the number and type of arguments passed to it. And what is inheritance? Of course, we are left with only one option, that is number B. So 4 will go with B. But let's just talk about inheritance for a moment. Inheritance means to allow one class to derive or inherit the properties of another class. Let's say if I had a car, in fact, if I had a class by the name of, let's say Alto, right? Say I have a class by the name of Alto. Now see, this class is also, this car rather, or this class, in fact, this is the name of my class. This is a class. This is a class. It is a car, right? It is the name of a car. Now, this class will have some common properties which is present for all cars. So what it could do is, it could derive this class, the car class, and it could also add some additional properties of its own. And this is what you call inheritance. Inheritance, mind you, helps you to reuse code, because the code that is written under car need not be rewritten under this class Alto, right? So that's how inheritance will help us in code reuse. So that's it for this video. Thank you.